Okay. Hello, good afternoon, everyone. My name is Antonio. I came nearby from the next province, from the University of Burgos. I'm working as a teacher, as a professor in the department of computer science. But I have to be honest with you, and this presentation, it's a biased presentation. I am not coming from forest or agricultural field, but also not coming from computer engineering, so I am just kind of in the middle. So I will try to present our just starting project, which is called Sen4C farming, and it's based in the quality or the recognition of soils. Okay, and I think it's very common and mostly known for every one of us, the important to have health soils, right? So the health soils give us several ecosystem services. You can see from the picture there how many services healthy ecosystem or healthy soils give to us. Mostly they are able to service the life on Earth. So it's important to keep the soils in a healthy way. However, intensive agricultural practices have depleted and have threatened these ecosystem services, and one of the most important, actually the second most important, is the soil organic carbon loss. We are depleting our soil from organic carbon, and now it's an emergency, mostly, to have a global effort, not just measure and managing of organic carbon, but also maintaining and hopefully increasing the stock of soil organic carbon, right? So in this scenario, during COP21 in 2015, the initiative 4per1000 was launched, and in this initiative, as you can see from there, the idea is to recognize the role of agricultural soils in food security. Of course, we are in the center, better or worse, it's important for us, but also for climate change, which again, we are the principal drivers, but also the principal affected by the climate change. So the idea is to have an annual increase of 4 per mil, or 0.4% of the soil organic content per year in the first layer of soil, using agroecological practices. So we have to change the way we produce food, the way we treat the environment. So with this information in mind, the proposal of this just a starting project again is founded in three, let's say, hypotheses where we can pick it up and take advantage of the Sentinel imagery to create free and open source input data that can be used to infer some agricultural management practices. So we will try to see if the artificial intelligence or any kind of machine learning algorithm are able to learn the management practices and also try to predict the soil organic carbon. One important thing is the introduction about this eco-scheme in the Common Agricultural Policy, because it's a payment rule, so we are going to pay from our fees. It's money from all of us paying for those people. So the idea is to be able to verify if they are doing well and how success are these proposals, because it has a cost for every one of us. Right? And of course, with this in mind, the increase of soil organic carbon in those agricultural fields will be an important tool, of course, for mitigate climate change, but also to reach these sustainable agricultural practices. Right? So the project of course has a machine learning approach, but the most important is to build this monitoring tool. Right? So we are going to give a tool for people, for stakeholders, for everyone which is engaged with the agricultural process, any kind of agricultural process. Based, of course, in the Sentinel imagery, trying to predict soil organic carbon, but also trying to predict the agricultural practices, right? We have three specific objectives, and you will see the translation into the machine learning approach. The first one is, of course, trying to teach the machine learning with the sustainable or not agricultural practices. So the idea is try to see if the classification algorithms are able to learn what kind of management has been used in some parcel. It's at parcel level. So the first specific objective is basically a classification problem. The second one is to predict the soil organic carbon. So in this case, we are trying to predict a number. So in this case, it's a regression problem. Okay. And the last one, and for me, I think it's one of the most important, is the development of a web application. We will see later, it's called machine learning as a service. So we have to give people the power to at least have this freely available data, but also the power of the artificial intelligence at hand. Right? So the idea is to combine both objectives to give the people the opportunity, and in this case, this is a software engineering problem. I am not a software engineer guy, so be careful with the question. Our approach, we split our project in 5 working packages, and as we have seen before from Felipe's presentation, and the importance of the data. Actually, I think the most important part at the beginning is to have good data to fit machine learning algorithm, and you will see later, but we are more or less here. Then we have to process the data, to apply the machine learning algorithm in a supervised classification. I have no more space here, but we have supervised and semi-supervised approach, we will see later. Using multi-temporal analysis, because as we have seen before, we have temporal data in Sentinel imagery, and of course the development of the web application that can be used as a tool. Okay? So, the project is here, right? So, yes. Almost what can I tell you is imagine how we predict that the project really goes. Okay. The first objective, the idea is to have verified information about what is the crop in some parcel, what is the management of this crop in this parcel, and try to generate image like this. Right? We have made some baby steps, the first step on this, and we have made some agreements, and I think this is nice. This is the way we should work, trying to make alliances, and we have made alliance with the project Soil Bio, because they are working with soils, focused in biodiversity and agricultural management, but also they're going to measure soil organic carbon. So in that case, we meet. And they have like 110 parcels in Castilla and León, so where is our project based. And we have, the classification of the parcel is a conventional tillage, which is the traditional way to farm, no tillage and organic farming. We will see here in different provinces the distribution of those parcels. So at the very beginning we are just collecting the information, picking up the information, but this is the first level of information because it is validated. The second objective, it's related with the soil organic carbon prediction, so the regression. Again, we need good data in order to create the prediction. We have planned, I don't know how many samples, but we have some budget to pick up samples and obtain the soil organic carbon in order to calibrate those field measurements with the Sentinel data. And also in the University of Burgos, we have a soil collection from the soil science department with more or less 2,600 samples. I don't know, probably the small screen you can see that they are mostly focused in our sampling area, so we are a little bit confident that we have data lead to start. Talking about the machine learning algorithm, we have seen that the most common one probably are the oldest ones. In this case, it's multiple linear regression, but also we have, I don't know, random forest, neural network, boosted regression trees, supervised vector machines, and so on. Right? But in this case, many of them have been used in a supervised way. So the approach we are going to follow is, in the first place, the approach will be used supervised classification and regression. Remember, we have two specific objects, classify or calculate the amount of soil organic carbon, but also in a semi-supervised approach. With semi-supervised, we have talked a little bit, Felipe talked about the energy consumption of this algorithm, and to have some algorithm with the comparable accuracy, but with the reduced number of instances, it's clever and energy-safe approach. So if you can train some algorithm with the half of the instance, you have the half of the time, half of energy to reach the same accuracy. Actually, in a parallel project, the algorithm we have trained in this semi-supervised, I don't know if you are familiar with semi-supervised, but the idea is you have some data and you blind part of the data. You remove the label that you are going to predict. You remove 5% of the data, 10%, 50%, 75%, and then you compare the accuracy. And similar, let's say, similar kind of data, we have reached until 50% with comparable accuracy of the model. So semi-supervised, I think it's a good approach. And also propose the algorithm that my colleagues have developed, like this is one is a little bit famous, rotation forest, but also democratic instance selection, random feature weights, and random values. Right? So the idea is to prove new developed, actually not too new, but new, developed algorithm in order to answer this. And the last objective, which is, as I told you, it's machine learning as a service, so we are going to give people, stakeholders, and anyone interested in this idea some easy to explore tool where we are going to put to the people level the prediction, but also to give the opportunity, we will see later some workflows, to give the people the opportunity to calculate soil organic carbon on demand. Right? So very, very general. The workflow for soil organic carbon prediction, you're going to start in some area, and the idea is to have a prediction of this soil organic carbon. In the area, if you are interested, if there already and Sentinel 2 image, for instance, so we create the algorithm with the prediction, and of course all the results are stored, and you as a user pick up the output and you see the prediction of soil organic carbon. If you don't have, or if we don't have this already image, then in the backend we are going to pick up the imagery, we are going to estimate the values, and of course the result will be stored in the same way, but also send to the user a notification that his query is already performed. The user, when the user wants to ask for data, which is soil organic carbon query, the idea is the user can go to some place, pick up some area, and to see how much organic carbon are there in that place. If we have some prediction, it's easy. Just pick up the prediction from the database and show the result. If it's not, the user is encouraged to look for the prediction, which was the first workflow. And finally, if you are, or if you have data of soil organic carbon and you want to create a prediction for your own land, for instance, or for your own municipality, the idea is to give the opportunity to the user to create a soil organic carbon prediction on demand. So in this case, you are going to upload plain text. It doesn't matter, a file with the carbon, with the soil organic carbon content. Sorry, I think this is not CO2, it's soil organic carbon. And the idea is to, if you have some Sentinel image in those places, modeling and forecasting or using your own data. In this case, you save the output and also give the output to the user, and the user is prone to share their data. The idea is to improve the machine learning model with real observed data, so the user can, of course, benefit from the machine learning model and pick up their prediction, but also, if he or she wants, can leave the data to keep training the model. Because in agricultural data, it's expensive. In some places it's mixed between public and private data. We left this open so people can choose to share the data and be a nice citizen or be a bad citizen. Okay, but it's open. And in the case it's not, okay, we come back from the first slide and open the satellite imagery, modeling this forecast, and save the results, and also send a notification to the user, in this case, with the prediction to himself with his own data. Right? So the further step, many. We are just starting, so we have many things to do. But one important thing, and this is what I really acknowledge from this meeting, is to look for collaboration, people interested in this kind of objective, and that's it from my part. Many thanks for your attention.